So our x component is the speed, 450, cosine of our angle, 288, 270 plus 18, 288. Our y component is 450 sine of 288. Our wind is 40 miles per hour blowing due west. Due west means it's going directly west. So that is what angle? 180. And it was 40 miles per hour, so 40 cosine 180, 40 sine 180. All right, so let's combine these. Okay, do the same thing in your calculator. Store these values. 450 cosine 288 plus 40 cosine 180. Store that as x. Write it down though, 99.058. Make sure that makes sense. Positive x coordinate, we're in the fourth quadrant, so yeah, we're good there. Okay, do the y's. 450 sine 288 plus 40 sine 180. Stored as y. Negative 427.975. Negative y makes sense because we're in the fourth quadrant. Okay, make note of that, quadrant 4. And it also makes sense that our y component is way more than our x component. If you draw your picture mostly accurately, you can see that you're closer to the vertical axis than you are to the horizontal axis. So you've got more vertical component than you do horizontal component. Okay, so let's find the actual magnitude. That is the square root of x squared plus y squared. This is our x, this is our y that we're referring to. Okay, so our actual speed is 439.29 miles per hour. Okay, this one's actually slowing down our plane because it's working against it harder than the other one was, since it's blowing due west. There's no cooperation there, I guess you would say. Our angle is the inverse tangent of our y over our x. So when we do that, inverse tangent, y over x, we get negative 76.968. Now, that's in the fourth quadrant. We just want a positive angle, so we add 360 to it. I add 360 instead of 180. I added 180 in the last case because I just wasn't in the right quadrant. I'm adding 360 here because I'm in the right quadrant. I just have a negative answer. I want a positive answer. So 283.032 degrees. That is acceptable. Or if they do it in bearing form, I subtract the 270 from that, so I am south 13.032 degrees east. So the plane is actually flying even closer to our southward direction than the pilot is putting it on course, because the pilot is accounting for the force of the wind pushing it the other direction. So this is how it's actually flying, but what was given in the problem is what the pilot is actually doing. This math actually goes on, okay? When you are